Hello friends, welcome to Susan and John MathTube. In this video, we continue our journey with complex analysis. In lesson number 1, we learned all the basic stuff that is necessary to learn complex analysis. Now let's jump into complex functions. So let's start. Okay, the first thing we have to understand is the difference between a real valued function and a complex valued function. If you do not understand this part, then when you learn applications related to complex analysis in your engineering subjects, or maybe when you learn major physics or in any applied subject, you will be in big trouble. So let's understand the difference between a real valued function and a complex valued function. So look at this. On the left side of your screen, I am writing f of x equal to x square. And on the right side of the screen, I have written f of z equal to z square. Now you might be in confusion. Both looks the same because here I am using the input variable to be x and here I am using the input variable to be z. But wait a minute. Here I am going to write x is a real number and here I am going to write z is a complex number. The graph on the left side can be created by plugging in real numbers and that function will square it. 1 will give me the output 1 squared, 10 will give me the output 100 and minus 2 will give me the output minus 2 the whole squared, because the job of this function is to square. So corresponding to every input, I'll get an output and we can plot the coordinates in a two-dimensional plane. So look at this. A one variable function ends up as a graph in the two-dimensional plane, and you already learned this in your high school that the graph will be an upward parabola. Now let's look at the function on the right side. Okay, look at this. Oh, wait a minute. The input is z. Do you remember in the last video I told you we represent complex numbers with the letter z or w. So I am supposed to plug in complex numbers as input. For example, if I plug in 1 plus I, then the output will be 1 plus I the whole squared. And that simplifies to 1 plus 2I plus I squared. That's not a big deal. You can simplify it. Wait. Do you remember I squared is minus 1? We learned it in the last video. And this 1 and I squared will get cancelled. And I end up with a complex number 0 plus 2I. Now I'm going to put the input 1 plus I and the output will be 0 plus 2I. Now starts the trouble. The input is a complex number, and from the last video you learned that to plug in a complex number into a graph, we use the two-dimensional system and we called it the Argand diagram. So the input itself is in two dimension. The output is again in two dimension. So what we do is we create the input plane called the xy plane, because I told you z will be x plus iy. And I'm going to call the output as w. And I'll assume the output to be u plus iv. And I'm going to call the output plane as the uv plane. So the input is 1 plus I. I hope you remember 1 plus I means the coordinate 1 comma 1. And the output is 0 plus 2I, that means 0 comma 2 here. Can you see? So are you able to understand the biggest difference between real valued function and the complex function is the graph of the real valued function exists in 2 dimensions, but the graph of the complex valued function exists in the 4th dimension. By the way, this is one way of visualizing the complex function. Some mathematicians take the input value and they take the output to be the modulus of the function. I'll tell you why. Can you see this is in the 4th dimension? And as a human being, I know 4th dimension exists, but I'm not able to see the 4th dimension. In order to escape from that 4th dimension, some mathematicians take the modulus of the output. Do you remember? Modulus means root under x square plus y square. So they take the input like 1, 1 and write the output as the modulus, and they will get the graph in the 3 dimension. And some mathematicians computer engineers, what they do is they take the complex numbers in the 2-dimensional plane, that is our x-axis and y-axis, and they convert the output into modulus argument form. If you don't know what is modulus argument form, first pause this video and watch the revision. It's very important. That is the r comma theta form. So corresponding to the input, we will get r and theta. Now you might be thinking it is again in 4th-dimension and our problem is not solved. Now what they do is they use some coloring technique with brightness and contrast. They will use color and the brightness contrast technique, and they will get the graph in 2 dimension itself. Anyway, many mathematicians have many different methods to solve the 4th-dimensional problem into the dimensions that we can see. Okay, so let's go for it once more. A real valued function exists in the 2-dimensional plane as a graph, but the complex valued function exists in the 4th-dimension. And one way to solve this problem is you take the input in the xy plane, just like keeping 2 monitors in front of you. In one monitor, you will take the domain, because every domain value is a complex number. And then in the other monitor, you observe the output. Just now I gave you an example. If you plug in 1 plus I, you get the output 0 plus 2i. So corresponding to every complex number I consider, I will get another complex number as the output. Usually we call the input plane to be the Z plane and the output plane to be the W plane. And to be precise, Z equal to x plus iy in our videos, and W will be called u plus iv in our videos, but in your application you can take anything that you like. Okay, so this is my xy plane and this is my uv plane. Okay, now look at this. In our real valued function, f of x equal to x square is a parabola, and f of x equal to sine x is a wave function. So it looks something like this, the positive part. But in our complex valued function, f of z equal to z square need not be a parabola. So look at this. Suppose I consider only this part as the domain. Can you see the domain contains infinite number of complex numbers, and the output will be another group of complex numbers. It can be the same, it can become bigger, it can become a parabola, not in the case of z square, but it can become a parabola. But there is no guarantee like in our real valued function that the output must be a parabola. So that is a very important point. So that is all with our complex valued functions. So I'll be back with the next video, and in the next video we will talk about the limits and continuity and something called an analytic function, and that is where the most interesting part starts. So till then my friends, bye.